Okay, welcome back. The last section we want to talk about is blended reality. This was a vision that it's been a little over 2 years ago that we rolled this out as an anchoring vision for how we look at the future. And that constant striving for how you can, our analog and our digital worlds merge, how our physical being and our digital realities come together in a reinforcing way. And to do that, what we're going to do is we're going to introduce you to the lab managers, and we're going to have them talk a little bit about blended reality and how they look at it. And then we're going to go out and we're going to tour the labs. We're going to walk around, and you're going to get to see, engineers in the wild or researchers in the wild, right? So you'll get to see native and talk to them and interact with some of the technologies that they'll talk about here and that we've talked about earlier today. So with that, I'd like to invite up, we have Keith Moore, who heads up our print adjacencies in 3D lab. He's also an HP fellow. We have Mirjana, and Mirjana heads up our experiences lab here, and a longtime HP labs employee who's had experiences outside as well. Ticky Thakkar. Ticky is the head of our emerging compute lab. And he is also an HP fellow looking at emerging compute models. And then finally we have Simon, and Simon is head of our security lab. So he'll have to kill you after he tells you what he knows. And he's based in HP Bristol. So
yeah, are we allowed to say his name?
yes. So please take a seat. What I'm going to do is we're going to just take a few minutes, and we're going to hear from each lab, talk about blended reality, how they approach it in their lab, some of the exciting technologies, and probably do a little bit of foreshadowing of some of the things you're going to see on the tour. And so with that, let's start with actually where blended reality began, which is around 3D and transforming manufacturing. And so we'll start with Keith. Why don't you tell us a little bit about what's going on in your lab?
Yeah, so our lab is the 3D and print adjacencies lab. And when I say print adjacencies, it's because while you know print well, there's other things you can do in that space. For example, we're putting down these like picoliters of drops, and a picoliter is about 100,000th the size of a raindrop. That's how to think about it. It's really, really small. We can do these billions of times a second. And this means that we can pump things along. So this is sort of the technology we work with, and we've applied it to 3D, which is sort of the core of blended reality. In this case, we can make parts, we can scan in parts, then we can adjust them and print them back out. And there was a person here from Shinola, way in the back. He sent me this query, which was, they had a little part for a phonograph, and it was sort of a piece that couldn't be easily reproduced, so they sent me the little file. So we printed this part. Now this is something that you otherwise would have to warehouse to reprint. So this is this notion of going from a digital environment, which happened to have a file, we could print it out, we could edit it, and then we can print it again. This is this round tripping of technology going physical to digital to physical again. And that's kind of the core of blended reality. So not only can we do that with 3D, we can also do that with other things you can pump around, and you can probably imagine those are things like cells, fluids, and other things of that nature. That's what we do in our lab, and we will show you this when you come down to the lab tour. So we're going to show you stuff that we don't normally show too many people, to be blunt. This is probably the first time at Shane's encouragement, is that the right word? To show you kind of what we do in our lab.
So tell me, Keith, what are you most excited about? What is the thing that gets you up in your lab every day? And I know your passion. So.
So there are two things. The first thing is there was a comment about diversity just a little bit earlier. We have everyone from our teams are mechanical engineers, we have chemists, we have material scientists, and biologists. And you're sitting there with these people who come together. And what's so exciting about this is that true innovation, true invention happens because they slightly misunderstand each other. So they tell them about what they're working on, and there's sort of this moment where they're trying to explain it, and in that explanation, it's kind of misunderstood. and what they come up with is even better than what the person was trying to explain. I love these multidisciplinary teams, and in my particular case, I think there's a fundamental transformation occurring in 3D and a fundamental transformation occurring in life sciences, where we have every opportunity to bring labs to where people are rather than people to where labs are. So this combination of elements, which can be technologically driven to transform the world, I'm all for transformation and looking forward to this in both the 3D transformation and in this microfluidics healthcare environment. So that's really what gets me excited every day.
Good. Can you maybe, I mean, we'll link two things here. Can you maybe say a word or two in maybe your foreshadowing here about how, you know, Raman spectroscopy can affect the milk supply?
Wow. Yeah, so we do work. We're actually doing it with the Food and Drug Administration, which is basically how do you sense individual molecules or contaminants that might be in milk, intended or unintended. And basically, how can we capture and identify those contaminants? So this is something we're working on. It's on a topic called surface-enhanced Raman spectroscopy, which is quite a large mouthful. But what it means is we can grab individual molecules, and we can basically hit them with a laser. And when we do that, they give off a little spectrum, and we can tell what we're holding within these tiny little nano fingers. So you'll get to see some of this. Now, it'll be very small, so you can't see it that well, so we'll show you something big that's really small. But it's very, very cool. It's very, very hard. A lot of what we work on may not make it to product. That's kind of the nature of labs. But the coolest part is when it does get there, it's probably the best thing ever is when a product actually comes out from something that was an idea and has made it all the way through to product.
Very good. Thank you. Okay, Mirjana. So Mirjana, you know, this is in the spirit of, we talk about diversity of thought here. Is Mirjana brings a background that's actually more in sociology, ethnography, and science of people. And so she takes a very different approach of how we look at problems. So Mirjana, why don't you talk a little bit about blended reality in your lab?
Yes, so first of all, welcome. I've been looking forward to actually telling the people's story, because I think with our company having the vision and mission that talks about improving lives of everybody everywhere, people are the center of it. So in my lab, we actually start with people, and we say that we are trying to understand people and their practice, whatever it is, in daily life, at work, in between. And then once we have that understanding, we bring that to ideas, how we're going to create some unique experiences and products and technology. So people first, very much so. My lab is very diverse, very much like Keith mentioned,
yep.
But it's a diverse along the lines of technologists, software engineers, hardware engineers, and then people who can understand other people, whether it's background in sociology, ethnography, psychologists, designers, quite a few of them. So all of them kind of bring a really unique and interesting mix of perspectives. What we tend to do is create something very specific. What we tend also to do is observe people in their natural environment. Here I'm holding a little mystery object. It's from one of our studies. And it was done specifically with this idea of creating something and putting it in people's hands. So we go into the field. We go into people's houses. We put these artifacts there. I don't want to call them products. They're not products yet. They're design probes. And then we come back and see what happens, see how people talk about their experiences. Because you can never sort of go and ask people like, well, how much blended reality would you like to have in 10 years? I mean, they need to see something concrete, something experiential, and then they can tell you all about their desires, their wishes, their aspirations, their goals.
Mirjana, seeing that wants me to take up my phone and make a phone call. And if you don't know why, you'll find out downstairs.
Yeah.
So that's a little hint, you're going to show them kind of the
This
snow
is just
globe?
a little hint. It's from one of the studies we did recently. It's somebody's house. It's a little 3D printed house done based on the images found online. And what we do is we find a person whose loved one lives elsewhere, and we leave the house with that other person to remind them. Many of you are probably not living in your childhood homes, but maybe you have some emotional reaction and tie to that home. So imagine having this kind of object in your living room, and some other magic things happen along the way.
You will see it, I promise you'll see a demo. And what I would say I find most motivating by the work that Mirjana does is that it really does focus on, we talk about the future of humanity, and it talks about people and experiences and how they react with things. And by studying that, we look then at how you can solve some of the most interesting basic problems. And the 3D house you'll see is, I actually find very powerful when you see it. I found it very emotionally attaching. As somebody who is on the road probably 90% of the time, it gave me a connection in a way that I never could have imagined. So hopefully when you take a look at it, you'll get an idea of what it really does. Your favorite project, Mirjana, that you've worked on since you've been back?
Gosh, this one ranks pretty high. But pretty much all of them, when you see, you move something in people. You see tears in their eyes. We recently did a study with pairs of friends where we asked them to write a letter for the future about their friendship. And this is very, you may think, strange task to do. But actually, it caused some serious thinking and retrospection. And people spoke quite openly and with lots of emotion about what friendships mean to them and how they would like to honor them in the future. And that kind of thinking gives us ideas what kind of interesting connected houses perhaps we can create.
Yeah, fantastic. Very good. Thank you, Mirjana. Ticky. So Ticky leads up our emerging compute lab, looking at what is the future of compute. So why don't you tell us a little bit about your lab and blended reality, how it comes into your space?
Thank you, Shane. So one of the key things is as you look at future of computing and look around you, you all have some devices in your hands today. You're very mobile, very agile. And we look at future of computing, and the lab itself has a deep history in computing. In our lab, which is the Emerging Compute Lab, we are looking at the next generation of future of computing. What's the future there? We see computing become ambient in that environment. What does ambient mean? Like air. Today you breathe air, you don't think about air, or you don't think about breathing. We see computing be the same kind of environment. Every surface you see becomes a live surface. There's sensors in the environment that senses you. There's a dialogue that you actually use to interact with computers. And how many of you have seen or used Amazon Echo today? So Amazon Echo today in my home, I just bought the second one because it's become such a useful device.
Home or a second
Echo? Second Amazon Echo in the same home.
Thank you.
Yeah, and it sits on our kitchen island, and almost everyone uses it today. And we interact with it. We get and if I see how my wife uses it today, hey Alexa, put on the music from my favorite playlist. And she uses it to put her shopping list, and she puts it for putting timers on while she's cooking. And in some sense, the use of tablet or the other device has kind of disappeared. And the only way you interact with this device is through voice. So voice becomes a natural language dialogue. It's not speech recognition. So that's the kind of things that we're looking at. But it's beyond just voice. We're looking at an environment where you integrate other senses in it as well. So you integrate the vision, you integrate natural language dialogue, you integrate the different modes of interaction. Maybe dialogue is appropriate or a gesture is an appropriate environment. And we see every surface to be live. Why we do this? We want to reinvent, and we are reinventing the office and the home. And we see a new way of interacting with the technology. We call this ambient computing when you put all of those technologies together. And today you will see, as you walk through the lab, a couple of early examples of this in a home environment and in our office environment.
So Ticky, how does ambient computing work with our existing computing, and what do you see the models of the future being?
So as you all see here, some of you have Macs, some of you have PCs, some of you have phones. We see a multi-OS, multi-system device environment. And you want to be able to interact with those devices, with the different kind of surfaces. And you'll see today in the lab, we'll demonstrate to you, a doctor bringing in, something on a tablet and it wants to instantly share without the regard for what operating system you're using or what device you're using. That, to me, is a very powerful paradigm, of doing those things today where, if you think about how long it takes you to start a meeting today, it takes at least 10 to 15 minutes before you get everything right. You'll see downstairs when we go through the lab, it takes instantaneous to set some of the sharing things, and that's what we're looking for. So it's the environment. And how do we play a part in blended reality? So we're fusing the physical environment, users' physical environment with their digital environment. And that's how Emerging Compute Lab also plays part in this blended reality as well.
Very good. Thank you, Ticky. Yeah. So Simon, you being our Brexit member here and representing our anchor lab in Bristol, right? And you really look after security for us.
Sure.
And security has such a pervasive aspect to all of the things that we do. Maybe you could talk a little bit about blended reality and how security intersects with that.
Sure, yeah, and I think it starts with maybe start with something that's not secret about what we do, is that the threat environment is appalling out there. And that starts with, I guess, the range of actors, the range of motivations for attacking, the different, it's just a large attack surface. And you see a democratization, I guess, of those attackers in the sense of the kind of tools and technologies that people can use to attack are available to more and more people. So that kind of has changed in the threat environment. So that kind of means that it's no longer a case of if you're going to be breached, it's when you're breached. So if we think about that in the kind of blended reality scenario, where you've got, today it's already true at the endpoint devices that we make, that's where people create and consume information. In the future, that's going to be where the sensing happens, where the actuation happens. That's where the users experience all the things. So these are going to be very vulnerable points, whether that's for authentication or just for the kind of experiences we create. So we have to think deeply about how we're going to do a better job of doing security.
So in security and thinking about that in our environment, when we have billions of connected devices that's sitting on the edge, we tend to today focus more on the computer and the threats that come into the computer or that email that we hit. But those end devices end up being, or those end nodes end up being some of the biggest security threats. And maybe we can take a simple example on the printer and talk about what happens on the printer and then what you do to try and protect against it.
Sure. Well, the printer is another endpoint device. I mean, it's worth remembering. It's got a computer inside it. It's on the network. You send a lot of confidential information to it. So there's a lot of reasons you should be concerned about content going to the printer. So the same kind of mechanisms that we want to bring to the PC, we need to be able to think about how can we secure an endpoint like a printer, just exactly as you said.
Yeah. And that leads to, you'll see, our laserjet printers are what we call the most secure printers in the world, which is where we actually lock those down so they don't become actually the on-ramp to many of the most dubious actors who come in with malintent. And then making sure we can expand that to all of the devices that sit out on that network in an Internet of Things environment here overall. So why don't you tell us a story about your the most interesting security threat that you've seen, and describe maybe just a little bit about how it might have come about and then some of the things you're doing to address it.
So I think there's hundreds, but the interesting thing is that kind of evolution, that kind of arms race that happens between the bad guys and what I think of as the white hat, the good guys. So you're constantly seeing innovation. Actually, I'm a fan of innovation. That's why I work in the labs. It is true there's a lot of innovation in the threat environment out there. And so I kind of see that yeah, there'll be one day where you're struggling to sort of spot malware. So we start to need to look at the behavior of malware. And then we see how malware behavior evolves. So one of the interesting things is how it talks to command and control servers, for example. So that's always evolving. So you kind of have to watch how that behavior evolves, because one day a command and control is static, the next day it's moving around all the time. So you've got a real interesting challenge how you're going to spot when it's talking to a command and control server. So one of the interesting innovations is then, okay, if we can spot the behavior of how it's actually talking to its command and control server, we can starve it of some of its instructions. So that's one of the innovations that we've got excited about, how we can get on top of that. So.
And you've had a model that you talk about resilience, and especially as we think about compute models overall, and kind of an analogy of your home locked up and you have to assume somebody gets in. So maybe talk a little bit about what that means.
Yeah, sure. So there is a mentality. I started at the beginning around, it's not a case of if you're breached, it's when. And I think that requires new thinking about security. We traditionally think, okay, we've got to build better protection, higher walls, and we keep having this arms race where they come over the wall, so we have to build a higher wall. I think we have to start thinking, and the industry's been getting there for a while, but this whole notion of we need to think about making security resilient. So we actually design in from the beginning the idea that we'll probably be breached, but we will detect it. And if we can detect it, then we can start to do something about it, remediate it and recover. So the analogy I like to use is just a natural one of a house. You will put some locks on your doors to stop people coming in. Maybe you didn't think they'd come through the windows. So then you'd put locks on the windows, and maybe they come underneath or through the chimney, or. And at some point, you can't say, okay, no matter how many locks I put on the door, they're going to get in. So we need to start thinking about, if they're in, I need to put the cameras inside so I know they're in, and then I can do something about it. And I don't model how you got in. I just worry about making sure I detect and mitigate for it. And that's the kind of mentality of having a resilient approach to security that we're trying to bake in to all our endpoint devices.
Okay. One last one, and then what I want to do is open it up. We got a few minutes for questions before we actually go out and we'll see the labs here. But I want to phrase a question both to Keith and to Simon here, kind of within the context of 3D and security. And we talk about this vision of the next industrial revolution and digital manufacturing. Is where do you see the threats in security in that future environment? And then what are some of the things you're doing to prevent it?
Well, that's a great question. The first one is when we first did 2D printing, turned out we were particularly good at sort of counterfeiting things, or people were using our devices to counterfeit things, mostly currency. So obviously we did some things to help that out, but that is actually one of the problems when you start being able to make parts is, okay, if I can make parts cheaply, how do I know that those parts are authentic and carry the brand promise that was from the manufacturer? And that is a really tricky element to figure out how to do right. Most of you know there are lot numbers, which are usually associated. Someone can look it up. Or if a part breaks, which isn't exactly the security threat, but more the forensics item of what part broke and what can I do to make it better. So this becomes an issue of, well, how do I know it's mine, particularly if there's a lawsuit? And how do I know, how do I reproduce it and improve it each time so I know what went into that process? So this notion of tagging, this notion of everything having an identity, every piece of paper has a thumbprint or a fingerprint, every piece or part we make will be uniquely created. You now can use elements about the randomness of these processes to actually create fingerprints for them and get everything to have an ID. So this notion of branding, identity as an element, and then tying that all the way back to being able to track and trace the pedigree of these parts. This to me is probably one of the most interesting parts about it. But I obviously yield to Simon here.
And I think that's a great example. And for me, I would always go to end-to-end security. So there was that whole vision that Shane's described today, where we're going through like 3D capture of an object, scan it all the way through to 3D print. There's a heck of a lot of workflow that goes on there. And if we're going to provide end-to-end security from that beginning point to that end point, in order to do applications like the track and trace that Keith supplied, there's a fascinating problem of how do we trust all that infrastructure? It's really, really challenging to build endpoint infrastructures by endpoints, whether they're PCs, 2D printers, 3D printers, where everything that goes on and touches that workflow of information can be trusted. So I think basically what we're doing as a lab is thinking, how do we build infrastructures with endpoints that we can trust? And that's how we'll have the foundations to deliver on the kind of vision that Keith just described.
Oh, and just one comment, if you haven't met lab people before, when we describe a problem like this, we get really excited about it because the bigger the problem, the more excited we get, because that means there's more we can do. So it's very odd, but if you ever want to attract researchers to something, dangle problems in front of them. They get very excited about these. And you'll meet some people just like this.
All right, excellent. So there's always talking about what we do in the labs, and then there's physically seeing it, interacting with it, and you'll get a chance to ask live questions, not only of these guys, but you'll get a chance to ask them of the researchers themselves who are doing the work. And just remember, these are very, they're PhDs in their particular area, and they think deeply about problems. And so you're going to get answers that are going to come from that perspective. With that, I do want to take just a couple minutes if we have questions we want to ask overall for the lab managers before we actually start the tour and go through the labs and see some of the technologies. Anything at all? Yeah.
Simon, future of passwords.
Well, there is let me take an easy, cheap one. In the future, with blended reality, all the ways we interact with the environment, it's going to transform. So it's not going to be a case of like you interact with information by typing into a keyboard and looking at files. There's going to be what you're wearing, everything about you is a part of how you are interpreted as you work around. So the whole notion of how you authenticate and then are authorized to do things will move on drastically in the next 10 years, I think. So, I'm sorry? Well, and we'll take good account of the privacy implications of that, since our chief privacy officer is over there.
Yeah, you no longer can just add a number. That's you have to. But there's a lot of interesting ways in which you can authenticate against that we explore. You'll probably see some of those.
Yeah.
Yeah.
Question for Ticky and Simon. Your two jobs seem almost counterproductive, well, sort of antithetical to each other, because if on one level you're getting multiple operating systems and multiple ways allowing the free exchange of data, from a security standpoint and from a privacy standpoint, that's a bit of a sort of hill to climb. How are you actually building that into the blended reality to ensure that data is both collected and is also secure?
Go for it.
Yeah, well, yeah. I'll start from a security lab perspective. One of the philosophies I think you have to have as a security team, which we are, you have to do security in an engaged way. You can't do security in a vacuum in the sense that what are you securing? So we have to work together with the people who are constructing, whether it's today's products or the blended reality products of tomorrow. We have to think, okay, well, that's what we're constructing. Now we have to operate and work out whether the security architecture thinking we've got makes sense, whether we need to be innovative with that. So it is a partnership in the sense of what we do when we look at those kind of scenarios. The security is absolutely a part of how we think about how we get it done. So.
Yeah, absolutely. We have to think security from ground up. It's not something you think about as attaching after you build something. And so this is something where we partner with Simon to make sure that all of the things we're doing has, we understand the issues, we understand what we're doing to mitigate it, and actually have a secure solution. And privacy also is very important in the ambient computing, because as you're going to see, a lot of things will be sensing you, as Simon was saying. The cameras looking at you, sensors, even sensing your voice, etc. So privacy becomes a big issue as well. Yeah.
Yeah.
Hi, so I have a question of Shane. How do you manage these labs? Are there any competitive mechanism for them to compete each other, or how does it work?
The key on that question is probably the word manage. Was in all honesty, I mean, what you have standing up here is probably 120 years of experience in the compute industry. So in many ways, you're trying to bring independent thought and approaches on it. I'm not pretending like I'm some master or anything. I'll tell you what I try and focus on. What I do try and focus on is creating a vision and creating a direction, right? And we anchor it around, this future of where humanity is with a simple vision. And then we look for the programs that we do, and we try and think about how they address those, and that becomes, the framing by which we do it. But it's a messy work, right? But by nature, it's messy, and you have, opposite views and opinions, and that I think out of that comes some of the creativity that happens.
Are there a flow of people in between the labs, or how's the hiring works?
You guys want to comment on that? I mean, you guys hire the folks from.
I have hired quite a few this past year.
Yeah, same here.
And yeah, we are constantly looking for ways of actually creating cross programs.
And we not only do it this way, so weave them in and out this way, is you want to do them out of the labs into the product groups. I mean, one of the most wonderful, I think, relationships we have is in Keith's world, where you see an intersection between what is maybe really advanced tech and a little wacky on the 3D side with delivering a product in the 3D space that you saw out in that space. And that line blurs pretty well. And one of the things we try and work on is a rotation program where people move from one to the other, so you get a different perspective. I don't know, anything you'd add?
Yeah, I would just make a comment that, so I'm on my 6th rotation through. I'm 30 years with HP. And 6 rotations where I get an idea in HP Labs, and then I want to see it come through to product. It's a very passionate thing when you're locked on an idea. You want to see it come out. And probably the easiest way to transfer things is transfer it to yourself. So go with it. And the environment is such that we can do that. And it's a really powerful way to bring really new technologies through. And we encourage that within our organization.
And there's a very long history of HP Labs in doing that, right? Where people have rotated in and out, and some of the luminaries of the industry have rotated in, even from the outside, into HP Labs, and gone vice versa. I'm always famous for quoting Alan Kay, right? And Alan Kay said the best way, to predict the future is to invent the future, and Alan was obviously one of the researchers in labs. From the 50-year history of that. So, anything you'd add, Mirjana?
Yeah, well, I was just going to comment as well. Well, I've been hiring in the security team. We've got a lot of millennials. They all come with PhDs in cybersecurity. But actually, one of the filters is how excited they are about the blended reality vision, because I think that's kind of what we're trying to create. So if they're excited about that, then I don't see there's going to be a problem in terms of engaging with other labs, and that's tended to be the way it's worked out.
Any other questions?